So yeah, today we have Chris, who will be doing a live coding of a Twitch clone, and hope everything works and is just as planned. So I think that's all from me. And Chris, the floor is yours.
Okay, awesome. Yeah, hopefully, yeah, this is coming through. So, yeah, so hopefully everything works. We'll see. This will be this will be pretty raw. So yeah, I will. So essentially, I'm going to be using all the awesome work that the Membrane folks and Software Mission has put together to do this. So I am like a complete WebRTC like noob and novice. So I barely understand how the pieces work. But the coolest thing they did is they implemented all this in Elixir, and it's just natively supported. So we can use building blocks that they put together, and we don't have to be experts. So you get to see me doing that today. So hopefully at the end of this, we'll be able to actually have this quote unquote Twitch clone. It's essentially going to be rebuilding like the same interface that this app that you're connected to, chatting with and watching me is doing. So we're going to like build the thing that we're build the kind of app that we're actually looking at, but essentially one-to-many broadcasts from peer-to-peer with WebRTC, kind of like Twitch. Okay, so let's go see some code here. So I have an Elixir app put together, and this is using the WebRTC libraries under the hood. So one thing that the Membrane folks put together is this set of LiveView primitives that basically encapsulate all of the fiddly bits that you need to actually get video capture and peer-to-peer video working in your application. So what I have here is just a stock Phoenix app plus one dependency. So there is a live X WebRTC library. I have a specific branch for this demo because I added a few things to show this off. But what this library is going to give us is primitives that kind of wrap up showing a video, all the little bits of JavaScript underneath to actually have the WebRTC peers work and be able to receive packets and show video for you. So I've dropped this live WebRTC package in the Phoenix app, and then all we need is a couple routes to get this working. And let's see, can chat tell me whether my resolution is actually working here? Because on my screen, I see an enormous player instead of the full screen. Let's see. Okay, looking good. Okay, cool. I had to refresh on I have an example display here. Okay, perfect. Awesome. Full screen Zed, that's what we want. Yeah, Zed got Vim bindings that are actually like decent. So they've always had Vim bindings, but they have like Vim markers. So I can say like MA and then go back and jump back to that point. So anyway, there's a couple Zed features that recently landed that allowed me to mostly use Zed full time. Okay, so let's hop in here. We need a couple routes. So if we go into our router, I have the homepage is going to be like the stream viewer live view. And that stream viewer live view is going to be where everyone goes to watch a live view stream. And then the studio is going to be something that you would gate behind each publisher to actually sign in and produce a stream. So this is going to be your like Twitch or YouTube studio to put together a stream and do a one-to-many broadcast. So I have a couple live views stubbed out here for this. So on the stream viewer side, we can use these primitives that the software management folks have put together for us. So if we go back to our stream viewer live view, this is going to be the home page. This is where there's going to be a subscriber. And the subscriber comes from this library. And again, this is like something that extracts all of the fiddly bits and lets you just like drop this into your project. So this subscriber module has a couple things for us. One is going to be a function component to render some video for each subscriber. So each person actually tuning into the stream will get to watch this. So there's a subscriber function component that we can render. And all these interfaces are very early, but the goal is that this can just wrap up all of the complexity for you. And you can say, I just want to render like a stream viewer here. And this is going to accept a couple things. One is going to be the actual socket that we have, because behind the scenes, and we'll actually go into this, but behind the scenes, this is actually going to start a nested live view, and we'll talk about why in a moment. And we also want to feed it some kind of subscriber state. So we're going to build this subscriber, and as that changes in the template, we're going to pass it in subscriber. Okay, and this is going to render an actual video tag for us. And I'm using my keyboard that's a little bit funky right now. Okay, so we have the stream viewer set up, and where does this subscriber assign come from. So we need to go actually build that. So in mount, we have this function that allows us to attach this live stream to this live view. So here I can come in and I'm going to pipe to subscriber attach. And this is going to do some handshaking behind the scenes for us. Because again, underneath the hood, this stream viewer is starting another process. Could be a series of processes, but in this case, it's starting. Well, it's actually a couple processes, but it's going to start a nested live view, which itself is a process, and there has to be some handshake back and forth to tell the live view what's going on. And I'll jump into that code in a second, but first I want to actually attach this here. Just going to make sure people are happy to see what we got going on here. Oh, Heeks. That's right. H-E-E-X. Heeks is the, I guess that's how we say it. That's how I say it at least. So yeah, Heeks. All right, so this subscriber function allows us just to wire up each subscriber. So this Z autocomplete is useless to me, but it's going to want the subscriber ID. So in this case, this is going to be like your actual user ID per user. Right now, we have no real users in the system. So I'm going to say everyone that visits this page is just going to be the subscriber. But this would be like your actual user ID here. And you would be authorizing the access to the stream here as well. So we're going to assume that you've already done that. And then the important part is the actual publisher ID. And this is going to be, again, something you're going to be authorizing where I'm tuning in to view a live stream. This publisher is going to be some, user ID in the system or something that's actually producing a stream. Do you have access to it? All of that we're going to leave to the dear reader to implement. But this is going to be some publisher. And we can name this anything we wanted. But right now, we're just going to call it publisher. So again, these are arbitrary. We're just picking them for the demo purpose. And then we need to give it the PubSub server. So this is going to be using Phoenix PubSub behind the scenes, and we'll talk about how that's neat in a moment. But essentially, as each of these video and audio packets are coming over from this individual person in the studio, we're actually going to broadcast them. Phoenix PubSub for that is it's actually going to make it just distributed out of the box. So if you load balance this app and scaled it to a cluster, doesn't matter where the broadcaster is, everyone's just going to be getting the video and audio frames. So that's going to be the just live broadcaster, name of the app, .pubsub. And then we have to give it a couple other options. This would work here until we went to deploy. So I want to actually add this now. So there's an ICE IP filter, and I actually don't know specifically what this is doing. So the software management folks can talk about this if folks are curious afterwards. But specifically, when I deploy this, hopefully later on Fly here, we'll actually have to do some different filtering because Fly is running on an IPv6 network. So I have this pre-canned configuration that I'm going to set. So if I don't add this now, it won't work later. And then we'll be like, why isn't this working? This is essentially just going to do some configuration for us behind the scenes. So this is a function that's going to be called in production. Locally, it doesn't matter. This is going to work without it. Okay, so we've set up this subscriber. Can I format this? We'll see what I messed up here. There we go. Okay, so -1 for Z for not formatting there. So it's borked on doing something. Maybe restart language server. Well, that's the way it goes. Oh, it's still initializing. Okay, we'll give it a second. Okay, so what this is going to do for us is set up this separate nested live view. So internally in here, this is going to render a nested live view. That thing's going to be up and running. And when we call attach, it's actually going to attach to this subscriber assigned. So it's kind of like allow upload for live view uploads. We have this handshake process behind the scenes between our parent live view and this child live view. And it's starting up and managing a peer connection, which is another process underneath. And we're going to be communicating with it behind the scenes. But the neat thing about using the subscriber attach approach is it's using LiveView lifecycle hooks. So you don't really have to know about this, but what we're doing behind the scenes is we're actually communicating with this parent stream viewer live. We're sending it messages, and we can write library code that hooks into the lifecycle of like handle info messages being called and have that library code do work without doing a bunch of code injection. You notice I'm not like using this subscriber module that's doing a bunch of code injection. Behind the scenes, the subscriber attach is actually just setting up, function-based lifecycle hooks. So I can actually show that real quick. We won't walk through all the code, but I have it right here. It's going to be subscriber EX. And the formatter, for some reason in this project, in Z added parentheses, so just ignore that on my adders. But the cool thing about calling attach here is what we're going to do is Phoenix LiveView has this attach hook function, which most folks probably aren't using day to day. But the attach hook allows you to programmatically attach to the Phoenix LiveView and Live Component Lifecycle hooks, basically. So you may have seen like an on-mount callback, which is a macro for LiveView, or you may have seen in your live session in your router, you have this on-mount declaration that is calling into this under the hood. But at runtime, you can also call attach hook yourself, and you can say like, I want to hook into handle info on this LiveView. So given any LiveView socket, you can then attach it to a hook to any handle info call. And then at runtime, when a handle info is invoked on this LiveView, anyone that's having a hook attached is going to be able to intercept events. So we can actually look for specific events that we care about in library code and say like, okay, when we have this attached handshake behind the scenes, we're going to intercept that from the LiveView process, even though this is landing on the LiveView process mailbox. And then anything that we don't care about, we have a catch-all clause that allows us to continue, and continue is going to then allow that to go downstream. Could be going downstream to another LiveView hook. It could be eventually landing in the LiveView process itself and your userland code to do your own process messaging. But you notice the one that we intercepted, we called halt, so we can actually like halt and intercept this handle info that the LiveView won't get. So this allows us to, in library code, do some handshake communication behind the scenes, which we've had this for probably years now, but most folks are unlikely to be using lifecycle hooks. But you really should be thinking about them, especially when you're thinking about LiveView libraries, because they're really powerful and allow you to avoid a bunch of code injection. So behind the scenes, this LiveX WebRTC library is doing a bunch of the WebRTC stuff that you don't really want or need to have to care about. So it's doing communication with the client with some JavaScript, which we'll see in a moment, but you don't have to write that JavaScript. And what it's going to be doing when this handshake is happening with the JavaScript client is actually handling its own messages. So this is a nested LiveView that is getting its own messages saying, okay, we have a WebRTC client that's connected. And in this case, we can start broadcasting events if we need to. We're waiting for packets coming over from the clients. And then ultimately, there are ways that we can communicate back with the parent LiveView. So let me go and find that. So this peer connection code is all lower level packages that are shipped with Elixir WebRTC. And if we look at, eventually we have this handshake. I'm trying to find where I actually call back into the caller. So there's some on-connected code. Yeah, so there's some lifecycle code that the caller can say, where if they want to hook into connections, like connection state changes, we can actually call functions that they pass to us. Or if they want to actually hook into the packet stream, we can actually do that as well. Let's see if I implemented that here. That might only be for the publisher. Yeah, the publisher is the only one that allow. Oh no, I have an on packet. Yeah, so the subscriber can actually hook into the packet stream. So if you wanted to do like video transcoding of the raw packets coming over, if you wanted to up in userland react to these packets, you could do that. We're not going to do that for the purposes of our application, but here's where I could say like on packet here, and I could write my own function that's going to get like, I think it's the publisher ID, the kind of packet. So you're going to get audio, video in the actual packet. And I could be doing transcoding here, whatever I wanted, without having to actually worry about how those things are being sent up. We're not going to be doing that, but you can then expose that at the library level. But this should be enough to render a video that doesn't really do anything for us, except there's going to be a tiny bit of JavaScript to wire up. So after LiveView 1.0, one thing I really want to do is ship collocated hooks, which would remove the need for this step. Let me just check the comments here. Looks like, yeah, looks like people aren't complaining. So if we look back at, where am I going here? The JavaScript, yeah. So once LiveView collocated hooks land, this could all be provided at the library level. But for now, one thing I've pre-added to this app is this create publisher hook and create subscriber hook imports. And this is, again, something that the LiveX WebRTC library provides. This is what the software management folks put together. So you just drop this in your application, you import these two functions, and then you just expose them as hooks. Because ultimately, internally, when you render from the library code that's going to be rendering Phoenix hooks. And all we're doing is just wiring them up to our own hooks that we then give to the LiveSocket constructor. So ideally so they just land in our LiveView hooks. When co-located hooks land, the library code could have just, blooped this down behind the scenes and you wouldn't have had to add these few lines. But for now, this is how it's going. Okay, so the few lines of JavaScript that were necessary in user land is there. And let's start the server, see what happens. Again, this isn't going to be very useful to us. Add or in use. I probably am running it here. There we go. All right, so if we go and open our browser, so we have this video that's not going to be doing anything for us because we have no actual publisher, but it's rendering something and it's kind of waiting for the stream to start. So that's progress. So go back to our stream viewer. I think we might be able to give a class to this thing, but just ignore that. We're don't need to make it pretty just yet. So then we need to go to the actual publisher or the studio side. So this is, again, your vast majority of users are going to be landing on the stream viewer, tuning in, let's say, to like your Twitch stream, and then you have one publisher in some studio or your app, Twitch. You have many publishers, but you're going to be having any individual publisher streaming out to many actual end users. So that's going to happen in our studio. So our studio should be reachable, but not doing anything now. Yeah, so it's a blank page. So the studio, we have, again, similar thing, some function components that can render render a nested LiveView for us and hook into the JavaScript hooks. Someone said chocolated hooks. Yeah, so some of that, Peter's saying about defining the hooks, you could write them inside the template. Yeah, so the goal for co-located hooks is you'll be able to write them inside so userland or library code could co-locate the JavaScript source inside, where the Heeks is located, where your Elixir code is located, your LiveView or Live components. And then that behind the scenes is going to be, sucked into your application bundle or however you want to handle it. It eventually needs to land in userland. It's just browsers are pesky. So this isn't a hard problem to solve, and we've have prototypes that we have messed with. I just haven't had time. The trickiest part of this is if you just embedded a script tag, it would work. But then you have like CSP to worry about. So you can't just do the script tag if you want this to be, real serious business. So you need to use like a nonce, or you need to use a hash, and you have all these like complexities then of like imparting that complexity back on the LiveView user, where like they need to get the nonce in there somehow. And so our goal is to like have folks not worry about that and essentially write it as if they're just embedding a script tag, except at compile time, the Heeks parser can actually lift that out and make it all content security policy appropriate. So the goal is, you essentially are going to be embedding raw scripts that could eventually land in a build tool or not, and you don't have to actually think about that. It's more or less just like co-located script tags that do the thing that you want to do, and then that makes the browsers happy and the security teams happy. But what we're going to do here on the publisher is something very similar. So we have a publisher attached and a publisher function component that is going to look, pretty much exactly what we just saw, just slight differences. So in this case, this publisher import has a studio for us. So the studio is a heavy function component because it's going to be able to render like controls for starting the stream, toggling your audio, video interfaces, and this library only offers kind of this giant studio function component, but you can imagine something in the future that has either different slots or different piecemeal function components to actually just render, let's say, the studio video, and then have you be able to access the controls. But for now, it's just a way for us to render a whole studio controller here that has all the UI controls for starting the stream and controlling like where my earbuds are going to be connected in video settings. So we're going to go ahead and pass the socket again here, because again, we're using a nested LiveView underneath. So you could implement this with a live component, but the problem with that is these video packets are being sent to or copied to a process, and if all that's happening in the UI process, which is your LiveView, then like any blocking work that you did. So like if you had like something that persisted a chat message and that took, let's say, 200 milliseconds, then you actually would see frames being like the video would pause because you're blocking the messages from receiving the video and audio packets and then having those relayed. So we want to use a nested live view here because we actually want the process isolation. So I always tell folks that like nested live views are you really only want them for two reasons. One is like you absolutely need concurrency, and you want isolation. So if you want both of those, then you definitely want a nested live view. If you need isolation, you want a nested live view, right? If a crashing of the child isn't going to affect the parent. But then in this case, it's specifically about like concurrency here. We want this process running, managing its own state, managing its own UI, and it cannot be, blocking or consuming the mailbox in the main live view process. So we're going to pass this the socket. It's going to be doing a live render underneath, and then we also have this publisher assigned that gets built for us. And this thing can be changing behind our scenes. It's like a data structure that holds the state of the actual publisher. And then we have a similar flow here where we're going to attach a publisher attach. And again, this is going to wire up those lifecycle hooks for us behind the scenes, do this handshake for us, be communicating back state changes with the live view that the caller code can hook into. So in this case, we need to give it the ID. This would be like your user ID. Again, we have a global publisher right now. So instead of your user ID, we pick the global ID publisher. But again, this could be anything. So this demo that we're building is only going to be a global one-to-one publisher to everyone, but you can imagine hooking this into a real application. It needs to know about our PubSub server because again, it's going to be using that PubSub server to actually broadcast across a cluster. So on the local node, it's just going to land as just like a local registry, but the moment we deploy this on multiple servers, then it's going to go out and do some cool stuff for us. So we want to go ahead and copy that ICE IP filter. And we'll make that there. It doesn't like my formatting, doesn't like my end. There we go. Okay. And there's like an on-connected callback as well that you can hook into when the JavaScript client basically wires up the WebRTC client and connects back to the server. So just to show an example, I could say, I think this is like the publisher ID. I could send, and these functions actually run in the context of another process. And because a lot of your callbacks, like you don't want to be copying all the packets to the live view just to send them somewhere else. So if you wanted to hook into this packet stream for your on packet callback, you wouldn't want to have that function run in the context of the live view because then you're copying the message just to send it somewhere else. So we actually need, if we want to send a message to ourselves, we need to grab a context of that out here. And if I want to send myself a message when I'm connected, oops, I can send to the parents, and I can just say that we're connected now. And this is like when the client, JavaScript client is connected back and it's ready. So then I can handle that in handle info. We could say I'm connected, pick a socket, and then we could update the UI with some state, let's call it, let's say connection state connected. Let's get rid of this. Okay, and then up here, we can assign some actual connection state. Look at that, autocomplete actually was useful there. And then we can render that up here. It's just our connection state. All right, so assuming this worked, we should end up with a studio function component that has a video player that allows us to start streaming, and all of the controls in the process lifecycle behind the scenes is being handled by this publisher module and this function component. So if we go to our studio, look at that, live reload's already behind the scenes recording me. So this is out and running, and here's where like all these device pickers are rendered inside that underneath. And this is where, like, if you wanted to really release this as a full featured library, the LiveX WebRTC project, allow this to be piecemeal or user editable, customizable. But for now, it's just rendering some markup for you, allowing you to control what's going on here. So let's make sure that I don't have any issues or questions here. Let's see. Got some DHH stuff. This is really fantastic. Fantastic. All right, cool. So I think we're working here. So yeah, so this, again, this is all like, there's JavaScript hooks behind the scenes that we imported that's driving this. Again, these audio, video selectors, how this video is being rendered and controlled, I don't know. This is what the software management folks put together. It's amazing. So with the publisher and subscriber attached, we get this out of the box. And the cool thing is once I click start streaming, behind the scenes, this is going to be broadcasting packets from the publisher, and they're going to be picked up by the subscribers, and then those subscribers are going to be sending those packets to the peer connections. I won't walk through all of that code, but I do want to show what's happening before we show off it all working together. So if I go to the publisher, this is going to be a nested LiveView process that eventually starts this peer connection. Yeah, peer connection. So this peer connection gets started up, the client communicates, and then as we get packets, let's look for on packet. As we get packets, the caller can hook into their own callbacks and deal with the packet stream. We're not going to be doing that, but it's just going to be very simpler saying when we get a message from X WebRTC that we have this RTP packet, we're going to broadcast that on a specific stream video topic and an audio topic. And again, this is based on the publisher ID, which right now is just quote unquote publisher, but this could be, you know, any number of publishers on the platform. And then the subscribers, again, because they wired up their publisher ID and their PubSub module, are going to be subscribing to this when you call attach. So there's another process behind the scenes at the subscriber level. And this LiveView is behind the scenes handling its own messages. And one of those is actually going to be getting the packets and then sending them to their WebRTC peers. So let's look for packets. Yeah, so we're subscribing to messages that we're getting from PubSub, and then we're just calling peer connection and sending those RTP packets to our peer connection, which is every individual end user of each of these LiveView applications. So that's all that's happening underneath, and the user up in userland doesn't need to know about it, but there's lots of messages going back and forth. Every packet, every audio and video packet is basically landing in a mailbox somewhere and then being sent to the peer connections and ultimately landing in the browsers that you all see. So let's see if that actually works here. So here's my studio. Let me go to, I think part of the problem is I have this stream up on another laptop on Safari. So I have to keep refreshing it because it messes up. So if we open up two windows side by side, I want to see what happens here. Let's see if I can do this. Move to the right side. Okay. Open up a new. So go back to the home page. So now I have a studio up. That's not what I want. Oops. Hopefully didn't show any proprietary information there. Where are we at here? I want to go here. And we want to go here. All right. So now this subscriber is waiting for me to start streaming. So nothing is happening because I'm not streaming. So I'm going to start streaming. And it should start broadcasting packets. There they are. So if I unmute this window over here, I can actually hear myself. And now we're broadcasting. And we could open up multiple windows. And it should be all tuning in. So yeah, so this is like real-time peer-to-peer. I've got multiple windows. This could be like 100 people watching. I'm going to mute this because I'm echoing against myself. And again, you could be hooking it into this packet stream to be sending the packet stream off to S3 for video on demand or what all the fancy features that they call it. But ultimately, with the a couple function components and nested LiveViews underneath, and all of the hard work that the software management folks did, we have the ability up in mere mortal user land to be able to write 10 lines of code and 2 LiveViews, and we have this peer-to-peer one-to-many chat going on. And again, if I deployed this on multiple servers, it would just be working, which is pretty awesome. And we can actually deploy this, but I want to add chat to it real quick. That way we can claim that we really made a Twitch-like experience. So let me go into the LiveView, but I guess I refreshed my actual chat stream, so I missed the chat. So is there any any questions that someone wants to repeat before we go into make chat. So someone said, did I catch this right? All video packets are distributed via PubSub. Yeah, so currently the way that LiveX WebRTC library works is just broadcasts all the packets on the topics that you give. And those topics will be derived from the publisher ID, which would be like your user ID. So that's something that you could do differently if you wanted to. So right now it's just going over distributed Erlang using PubSub. If you wanted to actually distribute that via any other means, message queue, your own individual TCP connection somewhere, you could do that. But the library literally that I showed off is just doing, it's getting the packets and then it's broadcasting them over distributed PubSub, which is remarkably good at handling messages. So the Phoenix PubSub system, it's been like 8 years since I benchmarked it, but we're seeing 500,000 messages a second going through in my MacBook as far as message throughput. I mean, at some point you will, let's say, clog the tube, so to speak. Distributed Erlang there's no privileged lane, so there's an individual TCP connection between nodes. So this is something to think about. But the other thing is the RTP packets are relatively small. I mean, there's a ton of them. So over time, you're going to be sending a ton of throughput through distributed Erlang, but they're not like huge messages where you're actually going to be blocking, like head-of-line blocking. So in this example, I think this is like totally reasonable for actual production workloads, but at some level, this got to be something you consider if you have, like I don't, I won't even, you have to measure, right? People don't like measuring, but you'd have to measure if you wanted to deploy this and support, let's say, hundreds or thousands of active streamers per server, you'd have to actually measure what your throughput was. But then we scale horizontally very easily, and then you could still be using distributed PubSub and having that work. You would just need to figure out, what that throughput looks like. It's probably going to ultimately be like a network limit rather than like an Erlang limit. But people have to let me know. McCord.tv, yeah. The code will be available. Yeah, they have a live publisher demo app. It's not using my branch, but yeah, all this code is actually currently out there. And then the actual code that you're seeing here is forked on my personal GitHub, but is actually public. But yeah, we'll make this more easily available afterwards. I was asking, what is S3 video on demand? So yeah, so video on demand is just like as I'm streaming from the app, if I wanted to be saving the video to some durable storage to be watched later on demand. So that's what I think Twitch gives you that, right? So you would want to like check a box and now you're recording, you're doing your live broadcast so people can tune in live and they can tune in after the fact, often referred to as video on demand. This is something that with like a tiny bit of code you could implement on your own, right? So if you went back into user land outside of library land, this is something where you could just like hook into the packet stream and be sending those packets off anywhere you wanted to be. This is where like I don't even know. I think when I was talking with the membrane folks, like I think you can take the raw packets and not transcode them. But anyway, you would be getting the packet streams and combining them into storage somewhere like object storage or wherever, what have you. Okay, so we have our podcast going here. So we add chat really quick so we can claim that we have re-implemented Twitch, right? And we're ready to take on the world. So let's go into, I guess, the subscriber live view, or that'd be the stream viewer live. This is going to be a very limited chat, but again, to be giving us the building blocks. So here's where we can actually, we should have added a title or something to show off our, I think this app has the core components. So there is like a header. I think there's a subtitle. So this autocomplete is useless to me. So let's go. Let's say that we're watching, let's say, subscribers, the publisher ID. And let's add a chat. So we need some kind of like chat container here. So we'll add like a div. What, you can see my terrible CSS skills, but Tailwind makes it reasonable. So this is going to be like what, space Y3. Give us some breathing room. And I have previously used some Tailwind UI snippet, write a bunch of markup. So I'm just going to copy this to make something reasonable looking. Is the formatter going to work here? Oh, what? Closing div, where? One extra? Maybe I had invalid markup. Let me get the actual stack trace. See if our error messages are good. What is going on here? Uh-oh, that took forever. Did it actually work there? Yeah, I'm just gonna blame. So I actually have really good results with language servers on VS Code, so I don't know why Zed's having so much trouble here. I don't know what just happened there. All right, well, let's just start the server and see if we get an actual meaningful error. Okay, so it does not like the enclosed tag for the span at line 23. Okay, let's check it out. Okay. Language server just wasn't giving us good feedback. And I don't know why mixed format was not erroring out. And then the div tag that I deleted could be added back. So basically read the stack trace is the moral of the story. And the formatter is working. So this is actually nice looking. There we go. Okay. So I have an example. Yeah, so this is like not working, but it's wired up markup, right? So we have username and comment and this timeline of someone commenting. So we need to actually make this dynamic with LiveView. So we're going through, this UL has a list and we're going to make each of the LIs a stream item. So here's where we can say we're going to consume a stream. We get the DOM ID out and some kind of message. That's going to be consumed from streams dot, let's just call it messages. And the ID of that thing is the ID that we consume. So this should be enough to consume the stream. LiveView is going to blow up because the assign is not there. So when we go through, let's see, it doesn't like this. Stream now, and this form is going to be a Phoenix form. So we'll call it, let's say on change, we'll validate the input. We're not going to do any real validation right now. So we'll just say validate chat, and then on Phoenix submit, let's say publish chat. And the formatter, look at that, beautiful. Okay, so validate chat, publish chat, and our inputs. We have the core components come with the input components, but since this is all styled and I'm not going to be using TwoForm or Ecto at the moment, we're just going to leave the raw markup. So we're going to say we have a username here, and then we can maintain the value ourselves with some username assign. And then we're going to have a body with some body assign. Okay. And our submit button is just going to submit the form, which is going to call our LiveView callbacks. So we'll have, we need to set up the stream first. So we call it messages. We're going to start as empty. And then we have assign, and we're going to assign, I think I said the username. Let's start it out as guest. And we're going to start out, the message body is just nil. And cool up if we start typing because we have handle events being called that we haven't implemented. So let's implement those. I think we called it validate chat. We're not, again, really validating anything real right now. So we're just going to maintain the user's input state. Body was what we had as well. And that's going to we're going to assign those back to the socket. This is where you would be using a change set and casting them with Ecto, getting the errors, showing the user errors. In this case, we're just going to maintain, and then you would be calling toForm to convert back to form state. But in this case, we're just going to be calling and maintaining that state ourselves. And we're going to be sending the same information from the client. And in this case, after we publish the chat, the body can become reset to nil. And here's where we could actually call into, some interface like, chat.publish message or something. And we could send it the username and body. We would be sending it probably some kind of, current user aspect. In this case, we're just going to say no one's authenticated, everyone's a guest. This is where you could be implementing some interface to publish the message. So let's go ahead and make a chat interface to be good citizens. So live broadcast or a chat. We're going to call it publish message. That's going to take, let's just take some attributes. And this thing is also going to be using PubSub. So you want to actually provide some kind of subscribe interface. And here's where you could be subscribing to, I guess, a publisher ID, right? Everyone is ultimately watching some individual publisher. So here's where you can use Phoenix PubSub to say, I'm going to subscribe to like Broadcaster PubSub and some kind of chat room based on the publisher ID. And when I go to publish the message, here is where I could like revalidate it, insert it with Ecto, rate limit it, whatever you wanted. And then I'm ultimately going to broadcast, if that was successful, over Phoenix PubSub as well. And here's where I can broadcast on some publisher topics. So in this case, we'll pass in the publisher ID as well. And the message I broadcast could be a struct. Right now, I'm just going to make it a empty map, bare map. So in this case, this is going to take. Well, we'll just pluck these out. Some body and a username. All right, so we're going to broadcast that. We could map it in a tuple or something if we wanted to, have the caller look for a specific shape of a message. And now we have some chat interface. So if we go to our stream viewer and do we alias the chat, we did not. So live broadcaster chat. All right, so when we go to publish a message, we have the socket subscribers broadcaster ID, right? So we take out the broadcaster ID, or sorry, the publisher ID, and we want to give it, these are really just going to be the adders here. So I could do some guarding, but I'm just going to pass these on. And again, you would be doing Ecto change set insert before all this, but for now, we're just going to say, hey, it all works. And then we reset our form. And then the only thing is anyone else subscribed, which we need to do up here. We need to say if we're connected. So anyone that joins this stream viewer live, we're going to say if we actually have a connected socket, because the dead view render, you could call subscribe. It's going to subscribe that process. For the brief moment that it's alive, anything that lands in the mailbox will just go away. So it's not something that you would need to do. It wouldn't be the end of the world, but we only want to subscribe if we actually have a publisher here. So in this case, my publisher ID is just publisher. So I'm going to subscribe if we're connected, and then I get handle info messages anytime someone actually posts a message. So the last bit of, oh, look at this. Not useful autocomplete, but we'll get there. So we'll say new message, and we get the message. And in this case, we want to stream this message. So the only gotcha here is our message needs to be keyed in some way. By default, we would look for a struct or a map ID field. You can configure that with stream configure. But since these are not really persistent messages, we have nothing to key this on for the stream to be trackable here. So I'm going to stream this message, but I need to give it some ID. So I'm going to cheat and just say that the ID is like a system unique integer. Be good enough for us, right? Okay. We'll go back to our stream viewer. So anytime someone posts a message, we stream that, and that stream will then come up here, hit this for comprehension. By default, it's going to append the stream item. Stream allows you to take the ability to put something into a stream at a specific index at the beginning, at the end. By default, it's going to go at the end. And let's see all of our errors that we messed up. So it does not like something about the chat. So error message unused. What's the actual error? Let's go back here. Well, I do want to maintain my username in case the client sent a new one. So let's do that. And I'm not actually rendering the message right now, but the UI works. Okay. So let's go back to that warning and do something with that message. So instead of saying someone commented, I'm going to say that the message username commented. And instead of lorem, I'm going to just say this is the message body. Now we have chat. And we'll see what happens here. Let's open up a couple windows. I don't have chat on the studio at the moment, but we could drop it in the same way, or encapsulate it into its own thing. But so let's say this is from Chris McCord. Hey, we have distributed pub/sub, but if you notice, I'm replacing that in place. So we'll see if anyone in the chat, I have to go back and scroll, had noticed why is this only replacing the container. It's because I didn't specify the container was a stream. So the one thing you need to do is tell Phoenix when we go to patch the DOM that this is a stream container. And it works. So now we have chat. You could add a stream limit, and stream limits on the client would limit the container to a specific item of stream. So you can implement an infinite scroll in both directions just using stream primitives, which is pretty neat. But for now, we're just going to say that they're going to pile up. You could put this in an overflow container to make it, more like a chat bar on the side. But for now, this is good enough for our purposes. So yeah, it looks like Kevin caught stream. Phoenix Update stream was missing. Awesome job. You earned extra credit. Justin, yeah, someone said stream insert. Yeah, so stream and stream insert are essentially the same. Well, stream insert is for one item. So if we go to stream viewer, I streamed this individual message here. So I could have called stream insert and to insert an individual item. It's just anytime you want to do bulk inserts, people would have to like reduce over the stream and call stream insert. But then if you're doing a stream insert or multiple items and you want to put those items at the beginning or at the end, what order do they end up in? So the bulk stream interface is usually more straightforward or collection doing stream operations. That's what I reach for, but yeah, both work. Yeah, someone linked an Imager icon. I'm not gonna click that. Okay, so let's go through and actually try to deploy this thing. But so if we go to our actual, just we didn't fork anything before we try to deploy it. Yeah, so I have a stream, it should be working. So now I'm going to actually try to deploy this from scratch. We'll see what happens. So if I go to our app, let's build a server. I'm gonna call fly launch. Let's see if this works. So yeah, this is actually gonna have to build from scratch. Let's see the app name. yeah, that's, can I change the app name easily here? Let's use I do want to tweak these settings. Yes. Am I logged in? If I have to log in, it's all over. Nope, I'm already logged in. Perfect. Okay, so we're going to call this, let's see, Twitch clone. Already taken. Let's call it Elixir Twitch. And let's add a little bit more memory. We don't need anything else. And now going to deploy this thing. Let's see if do I leak my secret keybase or anything? I'm not using this app after this, but nope, it said it and didn't print it. Perfect. Okay, so while this is deploying, let's actually see what's happening here. How hard to use WASM to get custom codecs? Yeah, when it comes to actually video encoding, so FFmpeg, I use ChatGPT to be my FFmpeg interface, so I'm the wrong person to ask, but that's an entire expertise in and of itself. But yeah, you could do, I know people have used like mscript and FFmpeg to WASM, so I don't see why you couldn't do it. Oh, Peter said he took Twitch clone. That's hilarious. Well, your Twitch clone, what I saw is far better than what we have here so far. So, fly production ready. Yeah, I mean, I'm running a 34 node cluster that's been up for years at this point. Asm plus Elixir. Version 1 of LiveView. I mean, LiveView is 1.0 RC7. We actually just had a new RC. So I think there's a 1.0 milestone that's only like 2 or 3 issues on it. I keep getting like super close, and then we have another issue we add to the backlog, but it's very close. I use it to host my RTP streams. Yeah. Okay, so let's let this build. I'm just going back through the chat history here. So the audio is choppy instead of the video. Interesting. Yeah, Peter also caught the mistake. Okay, so now my build worked. Yeah, it depends. So that was from scratch. So that build of the new app was from scratch, but any subsequent deploy, all those Docker image layers would have been cached. So if we made it like a tiny change to the app, the build would have been, like 10 seconds long. So if we go here and everyone's a good citizen and no one tries to beat me to the studio, we should actually be able to see like a stream inside a stream. So no one actually visit the studio because that's mine. Okay, so let's see if this works. So if you go visit elixirtwitch.fly.dev and I start streaming here, people are commenting. We have hello worlds, and audio and video should be going. Let's see if I unmute myself. Hello. Yeah. Okay. So I'm tuned in here, and yeah, there's our Twitch clone. This is on single fly machine. If I did a fly scale, and okay, so we have someone in Italy. So this actually would be interesting. We could prove that this works distributively. If I scale this to add, what's our closest Italy region? I could do Warsaw or FRA maybe. So if I scale count to region, I'm gonna do ID and let's do one in Warsaw. Nope, single region. Oh, did it give me high availability? Yeah, it actually gave me 2 machines instead of, let's do this. I am running 2 already. So yes, it's going to add this. No, I do not want it in ID. Why is this not working for me? You can see my fly CLI knowledge here. Where am I running currently? Should I have 2 in IID? Yeah, I have 2 in IID now. Did we change this? I just want to add one machine to Warsaw. Yes. Okay, so this is going to add a machine in Warsaw. If we do fly logs. So technically we already are distributed, but there's no easy way to tell if people are load balancing to both the IID Virginia servers. But there's our Warsaw node coming up. So it's already booted. So, again, because Flame, yeah. So we have people that are using the Warsaw server now because we're getting a bunch of EX WebRTC warnings, which should be fine. So yeah, someone in Warsaw that, assuming that they're connected from there, we should be getting our chat messages and the video should be playing. And again, this is all going over distributed Erlang across the world on Fly's IP physics network. Yeah, so Peter from the Netherlands, that's definitely going through the Warsaw server. So yeah, so there's our distributed Twitch chat clone. Just works again on the number of servers, any number of servers you're going to write, and this should actually scale remarkably well for just sending all this over distributed Erlang. So again, this is just out of the box. Like you just run Mix Phoenix new, you drop in a couple libraries, and now you have something that I would have thought is impossible to build even a few years ago just in Elixir. So really incredible work by the software management folks, the Elixir WebRTC library, and again, membrane folks, all part of all these same efforts. Hats off to them because this is, again, something that's incredible. And I think we need to talk more about it because it's awesome. So yeah, I guess I'll take questions if people have more questions, but that's my demo for the day, the deploy work. So I'm pleased with that. All right. Yeah. Questions back on the other chat. See, could you route clients to the same machine based on which stream they watch, is what Peter asked. Yeah, so Fly actually, you could do the routing in Elixir, but Fly has the ability to there's a Fly replay header. So what we could do is if you wanted to route someone onto a web server, Phoenix server, ultimately it's going to be like a bandit server. I'm not sure how this goes with the WebRTC routing, but essentially, yeah, we could actually tell Fly to just like replay to a specific machine. And I'm trying to think in my head. So like you're gonna land on the Fly server that's closest to you. So if you landed on the Warsaw server and someone was streaming from IAD, the question is, I'm assuming this is the question, Peter, instead of going over distributed Erlang across the cluster, could you just route all users to the local node that's serving the traffic and then do like just a local message send instead of going over pub/sub? Is that accurate? And the answer is you could. You absolutely could. It actually would be quite easy to do using Fly Replay. So you could send the Warsaw user, you could send the EU users back to IAD if the publisher was publishing from IAD, and you could actually send them to the specific machine. It's like I don't know why the app crashed there, but interesting. You could send them to the specific machine if you had 10 servers running in IAD and you rerouted them to you could send them to the actual physical machine that is serving the broadcast, and that's actually a really interesting idea. And then you wouldn't need to be sending the packets over all the packets over distributed Erlang. And the subtext of all of this is, the nice thing about that is you're not spamming the whole cluster, especially for big clusters. You're not sending the packets everywhere just to have the potential for subscribers to be there, because that's what the way pub/sub works is the message is sent one time to all across the cluster to all Phoenix nodes, and those nodes are going to then relay them to their local subscribers, which may or may not exist. So rerouting everyone to the local nodes would prevent the ability to having to send them everywhere else. So yeah, awesome idea. Definitely worth exploration there. But yeah, all the parameters are there to do it. And your code would the Elixir code to actually do this would be like 20 lines of code or less, including the Fly Replay and the pub/sub changes. Your pub/subs should just become message sends. Yeah, cool idea. Yeah, do it on a live stream. That would be awesome. I would tune in and watch you refactor that. Thoughts on deploying on Fly without disrupting streams? Keep blue servers around until the stream is over. This is a great question. I don't have any ops experience with running like video infrastructure. So yeah, the question is like, if you have these streams up and running in, you know, an Elixir or whatever infrastructure, whatever language is like these are long running. So if you know, did a deploy and bounced those users, you'd have to reestablish all the streams, all the connections would drop. That'd be, you know, a lot of misery. So yeah, I mean, blue green deploys would be one way is you just keep them around. And Fly does have the ability to you can like cordon off a host. So you could essentially mark it as like don't accept any new connections to it, but keep it alive. So like yeah, the overlap on like the Elixir shutdown story and Fly infrastructure for like a thundering herd problem, I usually try to stay within Elixir if I can, just because you know I try to stay not provider specific. But that's for like, you know, shutting down a server and having like, you know, draining 100,000 WebSocket connections. That's easy to do from Elixir because we have like this shutdown timeout that stages the shutdown and blocks the shutdown for a period of time. But when you're talking about streams, like the streams could be, you know, an hour long or more. In this case, like that's going to have to be something you do at the infrastructure level. And we have features for that, but it's not something I've ever staged out. But yeah, blue-green deploys on Fly don't expect the servers to be around that long. It's going to like wait till the greens are healthy and then tear the blues down. But the all Fly's infrastructure is built on like our machines API. So like what you could do is you would essentially be rolling your own blue-green deploy. So you would use the Fly API instead of doing a blue-green deploy. You would like cordon off all of the blue machines, have them not. That would means Fly wouldn't accept new traffic there. Then you would start the new cluster service traffic there, and then over time you could programmatically shut the old ones down. Like you could literally call a system stop on them when all of the final streams are over. But yeah, that's a hard problem and something that yeah I've never tried to do in practice. But definitely if you're building a real video service, you'll have to consider those things. Who deals with the Fly replay header? Cowboy. Yeah, so the Fly replay header is something you would just do like you would set the response header Fly replay to like a machine ID or a region. There's several options. And then you just do like a plug con send response. So ultimately it's going to be Cowboy or Bandit. We ship with Bandit by default. So if you're doing a new app, it's going to be Bandit. If it's an older app, it'll be Cowboy. So then the Fly proxy is going to see that response and then reroute and replay the original request with like the request headers and request body and everything. Yeah, they're recording. Awesome. Yeah, I didn't know if this was going to be recorded or not. So perfect. So why blue-green deploys versus just sending the new bytecode on a running VM? Yeah, so that was yeah. So this is actually a good point. So someone's asking like, why all this talk about blue-greens and bouncing users if you could just actually do a hot code upgrade? So you could. So Elixir would be a fantastic option for hot code swapping, especially for a video service. So yeah, most folks I think on the stream are going to be familiar with hot code swapping, but the Erlang VM allows you to just like hot patch code that exists, right? I mean, we could actually do it. Is this assuming my subscriber view is up here? I'll show you some example of hot code swapping here. So is this still working? Am I still streaming? Maybe. Oh, I had to actually re-click start. Okay, so my stream's up here. So one thing we could do, let me open up a new terminal. I'm going to do fly SSH console. And I'm going to shell into the running VM on, actually, this is going to be one of the IID nodes. So we'll actually see if I hit the correct one. So if I actually open up that release, it's going to be at bin live broadcaster remote. Yeah, so this is not how you would actually stage a release, but one thing you can do is I'm going to change, let's say, this LiveView to say like hello and update the stream title here. So if we actually go here, I'm just going to paste this into the shell and that recompile the module. So I reloaded it in memory. And if I refresh this page now, so I've hot code patched the running VM in IED only. So if you happen to be hitting this Fly machine, yeah, so the Erlang VM lets you do this, and you could actually write a little LiveView hook to be listening for code changes and actually forcing a re-render. So this could happen without actually the streamer losing the stream. So this would be a great example for hot code upgrades. It's just hot code upgrades and hot code swapping come with a bunch of other complexities. I'm exploring kind of like a worse is better approach to hot code upgrades. Someone may have seen my demos where on Fly I had hot code upgrades working, which Fly is a Docker-based example, but it turns out like it's pretty easy. Like you could just take all the compiled Beam files and unpack them on a server and tell the Erlang VM to load any beams that change on disk, and boom, you have hot code upgrades. It's just you're not doing any of the actual rel up stuff that is built into the beam. So you're not like handling versioning of code, doing the actual code change callbacks, doing all application configuration changes. So I think there's probably a happy middle ground there for people that like, in this example, like I just want to change the title on a web page. I shouldn't have to like build a release, test the rel up, right? But then that comes with a lot of foot guns on if you do mess that up or you add a dependency and you try to force this code upgrade, it's just going to be non-deterministic. So Elixir would be great for a video platform because of hot code swapping, but it's something that you're going to have to become more of an expert on because you need to test these things. Because the worst thing is like you do a hot code upgrade to not take the system down, and then you didn't properly test it, and now you took the system down trying to upgrade it. So yeah, definitely great question, and Elixir would be really well suited if one of the hard requirements was like working around this long running chat, right? Because imagine you had a stream running for 10 hours, right? At some point you need to tear down those servers if your blue-green strategy or your old set of server strategy is to eventually kill those things. So hot code upgrades would work around that. Yeah, great question. Yeah, and I have it on good authority that like the copying and pasting code into the RMSH shell is like how folks running Elixir and Erlang at scale have done like hot patches for like systems with millions of users. So it's actually really good in a pinch. Like if you're on staging, instead of having to like do a new deploy, I'll often just like poke around in the shell and recompile modules. Hot code upgrade would work with clustering. Jason. Oh, Elba Jason, what's up? Yeah, hot code upgrading with clustering, like again, this is like the added complexity of like you would have to be doing some rolling upgrade. You could do one node at a time, which is often what folks would do, like stage it out. But then you have to worry about like if you're upgrading the cluster one node at a time and you change the contract of the shape of messages that are being sent, now you could actually be like causing crashes in other areas of the cluster. So there's this whole other like you trade off one complexity for another, right? So it's like I don't know which is worse or better. It's going to depend on your requirements. Like if your requirements are to absolutely not drop a feed and you have people streaming for hours, hot code upgrades would be great. But then you have to adopt all these other complexities of like really testing these things, making sure that the changes you make are backwards compatible if you're rolling it out across the cluster, or you have some like process where you actually like cut the machine connection off from each other and upgrade and only allow clustering across like version code. But if you do that, you could be cutting actual connections and features. Anyway, so the whole can of worms there. But yeah, so I think I've been going for quite a while now. I'll let the moderator step in. I'm happy to keep taking questions, by the way. I just don't want to like, I'm not paying attention to what is going on behind the scenes here. If I need to get off, I'm happy to get off, but I'm happy to keep chatting as well. Normal risks of changing code. Yeah. I'm definitely, so like hot code upgrades for me is like, I'm really interested in exploring like the worse is better approach. Like if I just want to change something and I know I'm an adult about it, and if I mess up, I could always just do a cold deploy. I think that there's an unserved number of use cases for just doing like a forced upgrade. And I've been playing around with code that does that. So like the idea is like you just go unpack the change beams and you just the code changes, and good luck with the aftermath. But I think for a lot of cases, like that's what I actually want to have happen. So that's something that I may or may not be exploring later once I have some time. But don't allow me to get nerd sniped and procrastinate on LiveView. When you're writing a production level Phoenix app, do you design the module structure first, or do you go about programming the way you did on the stream and then refactor? Yeah, probably what you saw on the stream. I am very haphazard with my coding. That's probably why I like dynamic languages. I just kind of like, mash the keyboard and I generally start top down. So like what you saw on the stream is how I would have built it, right? Like I have some interface, right? And then like, oh, I want a video to happen here. And then this happens. And like, now what do I need to build to make the thing actually work? And then at the end of that, now how do I make it not suck? And most often it just works and it doesn't suck. But yeah, I work top down and then Jose comes in and works bottom up and tells me that like, Chris, you actually made 3 different things here, not one thing. But yeah, very much how I live coded it here, top down. Has anyone else seen someone other than Chris on his stream? I'm not sure what that's in reference to. Let me see what else we got here. Is it using the lib cluster? Yeah, someone else. I'm using there's a DNS cluster library that ships with new Phoenix apps by default, and that's like 50 lines of code library that just does DNS discovery, in which Fly gives you a internal DNS app.internal that will give all the servers on the network, and we just try them all in the library. So it's the easiest zero dependency multi-cloud feature that we could ship, but libcluster has other strategies like Kubernetes and a bunch of others that are definitely worth checking out if you need something different. Someone said no tests. Yeah, there's no tests here. I write tests as needed, mostly guilt-based testing, but tests are good and they need to happen. How do you think about integrating JS into Phoenix LiveView app? What mental models do you use? I don't really have a mental model for like I mean I use JavaScript as necessary. So like if I need to do charting, I'll throw a charting library in. I tend to vendor my JavaScript dependencies. I mean, node packages are plentiful, but like what typically happens for most of the things I'm building is like I don't have that many external JavaScript libraries, and like the things that I'm reaching for, the versions don't change that often, right? Like I'm not having to reach for npm to bring in like high charts JS or D3 every time there's a version change. It's just like I want to render this chart here and then I'll drop it in vendor at ESBuild to package it up and it's going to work 10 years from now. So I tend to bring things in. I mean, I'm not afraid of JavaScript libraries, just only if I actually need them do I pull them in. Regarding Flame, would you say it's a good way to encapsulate NIFs so if they crash, they don't take the beam down with them? That's actually really interesting. So I had never considered that. I don't, in my experience, NIFs have not taken out production systems for me. And I'm trying to think if I've ever had a NIF take out my VM anytime. And I can't think of a time. I mean, I've had seg faults at points, but it could have been like a weird Elixir Erlang version thing too, right? So yeah, I think that's really interesting. Like if you were going for like stability, mission critical, loading up NIFs inside a Flame could work. I don't see it would actually be incredibly easy to do. The only thing is you'd have to figure out how to build those NIFs separately. So the Flame fly backend allows you to like give it a Docker image that isn't the same image that's running on the parent, and you'd have to give it some. So yeah, so it's the only difficult part is like getting those NIFs built somewhere else and loading them, unless you can build them at build time, but then load them at runtime, and maybe that's what you do. But this is beyond my NIF understanding. So if you could bake the compiled NIFs into the beam and not load them, and then load them later programmatically, then this is like 10 lines of code and you're done. That would be cool idea. But I don't think it's necessary. But if this is one of your requirements, it's a cool idea. Have you ever had to fall back to some front-end library like Svelte, Elm, React? I mean, not for anything I'm building, but people absolutely do need to fall back, right? Like LiveView has its necessary limitations. So if you're doing like something that requires like, like I think like Spell has like an example where they have like a product visualization where you could like rotate a shoe. Like there's like a bunch of stuff that you're like, yeah, you're not going to do that in LiveView. But for me personally, I played around with Spell a bit. Like I poke around with things, but for anything that I care about building, it's like little bits of JavaScript here and there. It's not reaching for libraries, but they're there if you need them. I would love to see Phoenix move towards making WASM easier to add. Um, yeah, I mean, I think I've been waiting years for WASM to like get like a really compelling story, because it's a way to like maybe free ourselves from some of this JavaScript stuff, but it hasn't happened yet. So I think maybe we're there, or getting close to making this there. Like there's some really interesting libraries, like the PG Lite library is really fascinating to me. So I think I'm interested. I mean, originally I was interested in WASM from a like maybe I can write another language in the browser that's not JavaScript. But I think what surprises me is like the interesting thing is that like PG Lite happening where like now if I could run PG Lite inside like an Elixir WASM container, like embed a WASM runtime in the Beam and run stuff inside that, that would be actually really interesting to me. So in my head for years, it's been like I'm waiting for it to get really compelling on the client, but it's actually the coolest stuff I'm seeing is happening outside of the browser. So that kind of stuff would be cool. If folks have an interest there, I would love to have that be easier so I don't have to go down that rabbit hole. Yeah, and then with Flame too, it's like if you had a WASM runtime that you can embed in the Beam and you have Flame, then you have like 95% of what you would need to make like a function as a service and slap a credit card payment form in front of it. Three curses at once. Yeah, I don't know why I'm sitting here looking at myself doubled or tripled, but it's working. And the cool thing is though, like this screen that I'm broadcasting, like that, those are all PubSub packets that have been going, probably running hot across the cluster, right? I actually wonder if we can see, anyway, we'll do it later, but I wonder if I could see the traffic history on the Fly dashboard and see what kind of throughput we're getting on that app. Um, Cool. Yeah, so I think we'll call it there. I'm on Elixir Slack or Twitter if people have questions. But yeah, this has been awesome, and thanks so much for everyone tuning in and for Software Mansion for putting this stuff out there because super compelling. And we'll have probably on Twitter links to the polished source code at some point. But yeah, thanks everybody.